Well, I had my lunch in the meantime, so let's get on to part 2. Again, we need to factor that. So this is a perfect square trinomial, looks like. Maybe not. No, it's not. So k and k. 32 to add up in 12. How about 4 times 8? There you go. So our outers are 8, inners 4, add up to 12. Now the bottom, I think on your final you only get one of these. This is going to be a 5 and an 8 here. And our outers, inners add up to 13. Okay, that one's easy. Here we're just going to factor out a k here. And we get k plus 5. And this is a perfect square trinomial now. A 4 and a 2. So once again, we're looking for ones, anything divided by itself. So this is this. This one, this one. This one, this one. And it looks like our answer is k over k plus 2. And I have the work to support it. Okay, let's go on to number 15. And I'll write that out so you can see it a little better here. Square root of 2x plus 1 equals 13. Again, in our tool bag, you should have a tool for getting rid of radical signs. But the protocol would be to isolate the radical sign first. So we're just going to transpose that, and that gives us then a 12 on this side, and we get the square root of 2x equals 12. Now our tool is to square or raise to the index power this side, and we must do that to the other side. So this then becomes the radicand. And we're going to divide both sides by 2 now. X equals 72. And there's the work to support it. Now remember, I didn't write every single step, but enough to give full credit. All right, let's go on. We want to just continue our review. And here we're in complex numbers where we want to FOIL this and again show the work. So 8 times 5 is 40. Our outers, 8 times 9 is 72i. Our inners, a negative 30i, and our last, a negative, gotta be careful of the signs, 54i squared. Now again, you can check your work. First is 40, outers negative 72i, inners negative 30i, and last a negative 54i squared. But here we know that I squared is a negative 1, And we can then erase that I squared, which is a negative 1 times a negative, makes it this a positive 54. We are now asked to write this in our standard form, a plus bi. So 54, and this is a 94. Subtracting this gives us a positive 42i. And it looks like it's letter B for number 16. And that is correct. Okay, now in some cases on the final that I checked, students didn't have the correct answer, but they were showing some of the correct work. So I was able to give them partial credit. So let's write this out. This is what I would do if I were a student. 3 plus 4i divided by 8 minus 3i. Now the rule for this, if we are to simplify and put it in standard form, is to multiply our denominator by its conjugate, which is just the opposite sign. But remember, we're multiplying this by a 1, and our 1 is in the form of 8 plus 3i. So this would cancel out and just become a 1. But to, in a sense, convert this, we're going to use this technique. So 8 times 8 is 64. A negative 9i squared. Now I squared is a negative 1, so this will become a plus then. So I've eliminated one step. You can show it if you want. That would be a negative 9i squared. I squared is negative 1. Negative times a negative made this a positive. So this is going to become, as our denominator here, a 73. That's where this 73 comes from. Now we FOIL our top. So this is going to be a 24. Outer's a positive 9i. Inner's a positive 32i. And then our last will become a positive 12i squared. Now again, I wouldn't write this, but I want you to see it. This is going to be a negative 1. So this becomes a negative 12 here. So we have a positive 24 and a negative 12 gives me a positive 12 here. And adding these two together, we're going to get a 41i. Let's make that nice here. Got to get my eraser. I already said 41i, but there it is. Okay. Now, notice no answer is like this because it's not in this form. To put it in this form, we have to separate them. 12 over 73 plus 41 over 73i. Now it's in that form, and it looks like number 17 is going to be letter C. Right there. Perfect. Now again, you've shown the work. What happened is some people, they did this part correct, and they may have gotten this, but then didn't do this right. So I was able to give partial credit, even though they had the wrong answer. Okay, let's take a look at number 18 now. They want us to solve that. Let me write it big for you. Now there's more ways than one to do these, but I will give you what might be the general way of doing it. So we have here 7x squared, we have this, so I'm going to transpose that. On this side it becomes a negative 8. When I subtract 8 from this, it becomes this. Now I'm going to isolate the x squared by dividing both sides by 7. And I get x squared equals 81. Now, I take the square root of this side, plus or minus the square root of that side. I get x equals plus or minus 9. And notice what happens. We have a, which is just the plus 9, but here we have d, which is plus or minus 9. That is your answer. This is the work to support it. All right, now it looks like number 19, we would have to use the quadratic formula. So let's just do that. And it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And as a little review item, do you remember what we said was under the radical? What's that called? That's called the discriminant. And the discriminant determines the kinds and numbers of answers you will get. Now, in order to do this, you have to identify your A, B, and C when it's in standard form. So A here is 1, B is 1, and C is a 4. So we're going to substitute. So negative 1, negative B, negative 1, plus or minus the square root of b squared is 1 squared, which is 1, minus 4 times 1 times c. So this is all over 2a, which is 2. So this gives me then a negative 1 plus or minus the square root of, this is a negative 16 plus 1 gives me under the radical a negative 15 all over 2. Well, we don't leave it this way. We put the I, in a sense, out in front here. So let me just do that. The I would come over here. That would make this then positive 15. So that's basically your answer. And I see it for letter D here. Negative 1 plus or minus I, the square root of 15, all over 2. Now, in a sense, this isn't in standard form, so they don't always follow their own methodology that they want you to do. All right, let's go on. So here you could be standing on a building or wherever you're going to talk. Okay, we're going to take a look now at example 20. Said a coin is tossed downward with an initial velocity of 20 meters per second at an altitude of this many meters. So you can draw a little building if you like. And on the top of this building, you're going to throw a coin, but you're going to add velocity to that coin, and you're wondering when will it reach the ground. So over here, Your S is the altitude, so we have to put in there $158. But we want to solve this for zeros. So we have to transpose that to this side, and we get then 4.9 t squared plus 20t, which is your initial velocity of 20. Transpose that, 158 equals 0. So we have to find the zeros here. Now we identify our A, B, and C terms. Our A term will be this, our B term is this, and our C term is that. And then put it in the quadratic formula. Now, this is just tedious because it takes time to carefully put it in standard form, identify your A, your B, and your C terms, put that in the quadratic formula. Now notice you have a negative here times a negative, which will make this positive. So you multiply this times this times this, add 400 to it, take the square root of that, subtract 20 from it, and then divide it by this, which would be 9.8. And then your t comes out to approximately 3.999, and you're to round to the nearest second, tenth of a second, so this would make that a 0. We'd add 1 here, so your answer is 4 seconds. Now if you're going to use your calculator, which is what I did, I just put all of this into my calculator, this first, that, then I multiplied this, then divided this by this. In my calculator I get this, and that's enough of the work to indicate it. You don't have to keep putting more and more calculations. You're using your calculator. Now we're into chapter 6, module 6, where they're asking us to do some composition. Find F composed with G for X. And they're giving us our function of F and our function of G. So, how do we do it? Well, it's to take our G function, which is this, and then that becomes our X that we're now going to put into our F. So we're going to write this and square it, plus 3. So this is a binomial. We're going to square that, becomes 9x squared. Multiply these two, get a negative 15, double it, a negative 30x, and then square this, which is a positive 25 plus 3. Well, the only like terms are these, so this becomes an 8. And that's our answer. And which one is it? This one looks like it's A. This one, they didn't add the 3 to it, and these are not answers. Okay, let's go on. Raise it up a little bit. Determine whether the function is 1 to 1. If so, find the formula for the inverse. Now there's a recipe for this, and these are functions. And if we were to sketch the line of this, it would look a little bit like so. I'm just sketching that, and it's not accurate. So it passes the vertical line test, and it also passes the horizontal line test. This is a function, and it is a 1 to 1. So it does have an inverse. And this is the work you would need to show the inverse. You convert the function notation to a y and just write it out. You now exchange the x and y to start forming the inverse. So this will become an x, and this becomes a y. So we now have x equals 4y plus 5 divided by 9. Now the rule is solve for y. Well, we're going to multiply both sides by 9. If I change colors, that may help. So this becomes a 9, and here the 9's cancel out. So I can just erase them then. And then I transpose the 5. So I now have 9x minus 5 equals 4y. But again, I want to solve for y, so I'm going to divide both sides by 4. So now the 4's cancel out, and I have y equals this. But they want it in its inverse form, so it's g inverse. This is replacing the symbol for y, equals this now. 9x minus 5 divided by 4. So 9x minus 5 divided by 4, right there. 22 is A. All right, let's go on. Here we're talking about exponential growth, where we have the number of bacteria growing in an incubator culture increases with time according to this formula. So we have then the number of bacteria equals 4400, and then it's times 3 to the x power. Now, x is the time in days. Find the number of bacteria when x is 0 and when x is 2. Remember, you need to show the work. So, if x is 0, this x over here is 0, 3 to the 0 power is 1. So on that first day, before you start, there's no days, that's what 0 indicates, no days, this is just going to be 4400, because this is times 1 when this is a 0. 3 to the 0 is 1, so it's just this. So that's your first answer. Just got to find out what your second one is. Now the next one is 4400 times 3 to the second power. So this 3 Okay, as we look at example 24 here, let's take a look at that carefully. This is the expanded form of our logarithmic notation. We want to express it as a single logarithm, and if possible, simplify. So we have heard from previous lessons that when you have a plus between these, this indicates multiplication. When you have a negative, as we see here, this indicates division. So we're going to have log of base A. Something will be in the numerator, something will be in our denominator. Now our denominator, I can just do this one first here. You can do it in any order. It's going to be an x, and this exponent 3 is what x is raised to here. So this 3 in this form is placed in front of the log, which is what that is. The negative indicates it's in the denominator. So what do we have in the numerator here? Well, we have an x there. That's to the 1/2 power. And we have here a y that is to the 7th power. Okay. Now we don't have any answers that look like that, so we have to work with this, and it looks like we want to have positive exponents. So what is 3 if we're going to have exponents? That's 3 over 1, so I'm going to make that 3 here. Uh, 6 over 2. So that's a form of 3. So now when I bring down this 1/2 and subtract it from this exponent, I now get log base A of y to the 7th over x to the 5/2. And let me clean that up a little. And now we can see our answer is this one. Notice I don't like the way they've written that. That's the proper way to write it, but I guess that's how they wrote it there. Okay, so again, you can always go back. There's a lot of theory in here referring to what we had during lessons to show you how this actually occurs. This is the work you would need to support your answer. And let's raise it up a little bit. We can see it better that way. All right, number 25. Where appropriate, include approximations to the nearest thousandths. If no solution exists, state this. Now, here this is sort of tricky because we have a base 3 to the 2x plus 1 power, and we have this number 243, which is 3 to the 5th power, I believe. Let me check that. And that is correct. Now we said if our bases are the same, then the exponents have to equal each other. So we now transpose that. We get 2x equals 4 x equals 2. And that is D. So the key was to look at this and see that it was a perfect cube. Well, it was 3 to some perfect power, I should say. All right. So 3 to this power, 3 to this power, the powers equal each other. All right, let's go on. Number 26. Now, again, this is in an expanded log form. So we want to write it in its condensed log form. So it's log of base 10, which we don't write since it's the common log, of x plus 4 in parentheses divided by this, because that subtraction indicates division, equals log base 10 of 2. Now, since this is an equation, we can divide out the log. So we now get x plus 4 over x minus 3 equals 2 that we can put over 1. Every number is over 1. So we can cross multiply, I should say here. We get 2x, this one, minus 6. We're doing this. 2x times 2 times x, 2x. 2 times a negative 3 is negative 6. Equals x plus 4. Subtract x from both sides. We get x. Add this. 6 to both sides. We get x equals 10. Which is letter C. And again, as long as you know the technique of what's going on, this is the work. It's not too much. All right, I think we only have one more to do on this page. And let's check it out. We can raise it up a little bit. Now this one we're going to put into its modified form. Again, this indicates multiplication, log base 9 of x minus 5. Addition implies multiplication, x minus 5 equals 1. So this is its logarithmic form. We want to put this into its exponential form. So our base, 9 to the first power, equals, and we're going to multiply this together and get x squared minus 10x plus 25. Now again, this is the concentration of this. This is the expanded form. This is the singular form. We're now going to convert it from its logarithmic form to its exponential form. 9 to the first power is this. Once we multiply, now we're going to integrate this into that. So we get x squared minus 10x. Now we're going to subtract 9 from both sides. So we get plus 16. And then now this equals 0. We're now going to factor this. X 8, 2. And our signs need to be, this is negative and this is positive. So I'll write it over here. X equals negative 2 or X equals 8. Now we had said that you cannot have a negative value here as a log. So if we put a negative 2 in there, that would make this a negative 7. So that's undefined. So our negative 2 is not an answer. So our only answer is a positive 8. And that's what our work shows. And we have shown the work to support our choice of answers. And hopefully this is helpful. This ran another 40 minutes, but I think serves as an excellent review in preparation for your exit exam.